It is my great honor to be here to introduce your work about Chitosan promoted spheroid stem cell uptake study of two PET imaging agents. One is Feonm Feonm, the other one is Feonm F-18. The outline of this talk has three parts. The first part is design, preparation, and purification of our tau protein PET imaging agent. The second part is Chitosan promoted spheroid stem cell preparation and cell uptake studies of PET imaging agents. The third part is the docking simulation studies of tau protein PET imaging agents on another protein, beta-amyloid tetramer 6rHY. Tau protein is the cytoskeleton stabilizing protein. Design a new tau protein PET imaging agent. We apply the third factor to design our tau protein PET imaging agent, lipophilicity. The design rationale of our tau protein PET imaging agent is by adding 2 carbon and 1 oxygen atoms to its original compound as figure B, FDDMP, to increase its lipophilicity. Preparation Feonm Feonm tau protein PET imaging agent. First, we synthesize the precursor, Feonm, and then we use hydrogen fluoride 18 to react with the precursor to produce our product Feonm Feonm. The separation of the precursor Feonm, also named TON, and the product Feonm Feonm was done by Fortis diphenyl semi-preparative column. The retention time of the precursor TON is at 13 minutes, and the retention time of Feonm Feonm is at 12 minutes. The precursor has been decomposed during radiofluorination. The upper diagram shows the amount of the precursor of Feonm added is over the detection limit of UV detector. Lower diagram represents the precursor has been largely decomposed during radiofluorination. Radiofluorination yield of Feonm Feonm reached almost optimized condition at 95 degrees C. The amount of this study is at 7 mg precursor, and the spiking time is at 5, 10, 30, 60, 90, and 120 minutes. The region of interest was determined by radio TLC activity ratio. R square show little different from ROI and non-ROI, which represent the variance of activity distribution peaks. The full-wise etough mean of the product has shown that the solid extraction method is larger than 1, and the diphenyl column purification method can have less than 1 full-wise etough mean result. After prepared Feonm Feonm, the lipophilicity has been measured by gold standard shake flask method, and the log P of Feonm is 2.2, which is a little bit higher than its original PET imaging agent, FDDMP, 1.93. The tau tangle transgenic mice PET imaging of Feonm Feonm is higher uptake on its hippocampus than cerebellum, and the Feonm uptake on beta-amyloid transgenic mice is also higher than its original compound, fluorine-18 FDDMP. From the STZ-induced tau protein animal model, we also found fluorine-18 Feon is highly uptake on the hippocampus. Dynamic fluorine-18 Feon imaging in the brain of both beta amyloid and tau protein transgenic mice has shown that the uptake on the transgenic mice is higher than the wild-type mice on its hippocampus to cerebellum. Here is the human adipose-derived stem cells, which is isolated from human adipose tissue in ADSC cell culture medium at 135 days. The morphology of ADSC cultured directly on tissue culture polystyrene TCPS is figure A. After cultured on chitosan-coated TCPS, spheroid stem cell was formed on the chitosan-coated TCPS, as figure B. The stem cell uptake of fluorine-18 Feon. Chitosan-promoted spheroid stem cells increases at least 15-fold, which represents high cytoskeleton stabilizing power in chitosan-promoted spheroid stem cells. Stem cell uptake of another PET imaging agent, fluorine-18 FET. Chitosan-promoted spheroid stem cells increase more than 30 times. This represents high protein synthesis ratio in chitosan-promoted spheroid stem cells. Since we found the designed fluorine-18 Feon tau protein imaging agent not only uptake on tau protein transgenic mice, but also uptake on beta amyloid transgenic mice. So we make a study on the fluorine-18 Feon docking on beta amyloid tetramer. This tetramer is named 6RHY. And from the force field analysis, we found the extra 2 carbon and 1 oxygen atom in the fluorine-18 Feon formed a fluorine hydrogen bond, which dominate the main docking force and is higher than its original compound, fluorine-18 FDDMP. The major docking force of the original PET imaging agent, fluorine-18 FDDMP, docking on 6RHY, is the nitrogen carbon hydrogen bond on its malonitrile group, docking to the C-chain peptide of 6RHY histidine amino acid number 14. And the major docking force of fluorine-18 Feon is the fluorine hydrogen bond docking to the glycine on the C-chain peptide number 37 amino acid of 6RHY. The docking force of fluorine carbon hydrogen bond is much higher than the nitrogen carbon hydrogen bond, and the fluorine hydrogen bond was formed due to the structural change by 2 carbon and 1 oxygen atom over here, which make the significant docking force on the fluorine-18 Feon to 6RHY. Here is the interactive docking energy of tau protein PET imaging agents on 6RHY. Our PET imaging agent, Feon, is significantly higher than other PET imaging agents of tau protein. Relative docking force of tau protein PET imaging agent. From this figure, our tau protein PET imaging agent Feonm and its metabolite Feonm1Bn is significantly higher than other tau protein PET imaging agents. Comparing PET imaging of beta-amyloid transgenic mouse brain hippocampus ratio to the interactive docking energy, the left hippocampus is 1.7, and the interaction energy is also 1.7, so it's 100% saturation. After analyzed by Welch apodization gap area equation, we found the right hippocampus is 93 saturation. Fluorine-18 Feonm is a new molecular structure by adding two carbons and an oxygen atom between the fluorine-18 atom and other atoms of fluorine-18 FDDMP. This rationale of structural design is for improving the lipophilicity of fluorine-18 FDDMP and to prove the binding PET imaging effect on tau and beta-amyloid proteins. Even though the binding effect of fluorine-18 FDDMP on tau protein will be reduced by adding two carbons and one oxygen atom for forming F-18 Feonm, the beta-amyloid transgenic mouse PET imaging and the beta-amyloid tetramer 6RHY simulation results have shown higher uptake than fluorine-18 FDDMP. These experimental and calculated results meet the design rationale of increasing the lipophilicity with slightly structural modification will cause the sensitivity of beta-amyloid-related protein increasing. Conclusion: Chitosan could promote the self-assembly of adipose-derived stem cells to form 3D spheroids. These spheroid shaping coagulates showed better self-renewal property, differentiation capacity, and engrafting potential. The uptake of fluorine-18 Feonm between chitosan-promoted spheroid adipose-derived stem cells and non-chitosan-promoted adipose-derived stem cells can show the coagulating similarity between stem cells and tau proteins. The stem cells uptake of fluorine-18 Feonm maintained a high level within 30 minutes and then gradually declined at 60 and 120 minutes. Moreover, the chitosan-promoted adipose stem cells spheroid uptake of fluorine-18 Feonm was at least 15-folds higher than that of non-chitosan-promoted adipose stem cells, and for fluorine-18 FET is more than 30 times. These results suggested that highly increased chitosan-promoted spheroid stem cells uptake of fluorine-18 Feonm may have higher association with tau protein differentiation. Acknowledgements. Thanks for your attention.